Hey everybody, Mr. Judson here. So we just talked about how to solve exponential equations, which means we've got the variable up in the exponent, and our rule is we want to take the natural log of both sides and be able to bring that exponent down in front. Okay? What we want to talk about today is logarithmic equations. And so if you notice a difference, here I don't have a log function showing up. I've got my variable in the exponent. Here we either have like a log or a natural log of something. And so what we want to look at is how do you solve those? And then there's a couple different versions of this that we'll see for today. Okay? So let's just take this equation and work our way through that one. First of all, anytime I'm not sure what to do, this is just a good rule to remember. If I'm not sure what to do, always consider switching from logarithmic form to exponential form, or vice versa, okay? So I want to take a logarithmic equation and turn it back into something like this. So what I want to remember is that a natural log really means log base e of x, and that's equal to 4. And if I swirl that, I get e to the 4th power equals x. Well, there we go. The goal of solving an equation is really to get x by itself. And so I've got x by itself. There's my answer. And a lot of times people will stop right there. And they'll leave it like that. And the reason they leave it like that is because it's an exact answer. Right? I haven't rounded anything yet. All right, for those of you who like numbers, okay, you'd rather see a number answer. We look at this and it really doesn't make a lot of sense. Like, what is that? I don't even know. All right? So if you're the kind of person that likes a number answer, you just have to go down here and get your e raised to the x, punch in a 4, and there it is. We got 54.598. Okay, either one of those is a good answer. Right? Now, we should really start talking about this and kind of focusing on it with our Central Washington final coming up. There are times where Central Washington will say, give an exact answer. Solve this equation and give an exact answer. Well, then you want to make sure that this is the answer you give. All right? If you give this one, you did a good job, but we didn't fully follow the directions, so minus a half point. Right? We're all tired of minus half points. Right? We don't like those. So we just got to make sure we read carefully and pay attention to what we're supposed to find. All right, let's try another one. All right, so of course this one looks a little more complicated than the last one, but that's what we do here. We try to make each one a little more difficult so we have a broad range of understanding here. So one of the rules that we want to make sure and follow is kind of like when you solve an exponential function. We wanted to isolate the base and the exponent first before we started solving. Well, I want to do the same thing here. I want to isolate the log function. And when we say log, we mean either common log or natural log. Okay? This refers to both. So I need to get this part right here by itself. And so in order to do that, I first of all have to get this term by itself. So I want to get rid of that -7. I'll move it to the other side and add. So this is going to become 3 natural log of 4x equals 12. And then I want to get rid of this number, so I'll divide both sides by 3. Or you can think, just move it over and divide. So you get natural log of 4x equals, if I divide by 3, I get 4. So I have now isolated the log function. Okay, my next step, convert to exponential form. So remember, this is log base e. You don't have to write that down. If you want to, you can. You can say log base e of 4x equals 4. And now we're going to swirl it, switch to exponential form. So I've got e raised to the 4th equals 4x. So e to the fourth power equals 4x. We just saw what this was equal to in that last problem. And so now to get x by itself, I just have to divide by 4. So x is equal to e to the fourth over 4. Now again, that's an exact answer. If you want to stop right there, that's perfect. I like it. If you want a number, if you just like to see the number there, that's okay too. We'll just say x equals, I'll go back to my calculator. Let's see, I just did e to the fourth, and I got 54.598, so now I just need to divide by 4. And there we go, 13.650. All right, let's try another one. All right, we got natural log of the square root of x minus 8 is equal to 5. You guys go ahead and try it. See if you can solve this and figure out what x is equal to. All right, so my first step was to isolate the log function. I've already done that. Now convert to exponential form. So if this is log base e, you just go ahead and write it. Log base e of the square root of x minus 8 equals 5. I want to do e to the fifth power equals this square root. So e to the fifth equals the square root of x minus 8. So again, this is just a number. I got to remember that. If I grab my calculator and go e raised to the fifth, I'm just going to get some number. Right? So I'm okay leaving it like this and just thinking to myself, it's some number. I don't have to know what that number is. If you're like, no, I really got to know. Okay, grab your calculator, and we're going to do e raised to the fifth power. And all right, there it is, 148.413. All right, there we go. We know what the number is. But I'm not going to change it. I'm just going to leave it like that. I just know it's a number. So now to get x by itself, I first of all have to get rid of the square root, which means I need to square both sides. So if I square this side and I square this side, I know that over here I'm going to get just x minus 8. Here I got to think when you raise an exponent to an exponent, you're supposed to multiply those. So that's e to the 10th power. All right? Now, I always felt like if you don't remember those rules, you still ought to be able to figure this out. I think the thing that frustrates me as a teacher is sometimes people look at it and go, oh, I don't know what to do, I'm just going to add them and get 7. It's just a guess at that point. Well, what does an exponent mean? It means do e times itself 5 times. Let me just go off to the side here. E times e times e times e times e. And I want to do that twice. So e, 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 e. 5 more e's. So what do I have total there now? I've got 10 e's. So this whole thing is e to the 10th. Okay? That's what I mean when I say, if we just stop and think. Sometimes I think we just don't want to do that, But if we just stop and think a little bit, we could probably figure that out if we forgot the rule. All right? All right. So now I just have to add 8 to both sides. So x equals e to the 10th power plus 8. There it is. There's my answer. That's an exact answer. Do I know what it is? I've got no clue. No idea. I don't even care. I mean, I care, but not enough. I don't feel like I have to punch the calculator buttons to see what that is. But if somebody does, that's okay. Grab your calculator. Let's go e raised to the 10th power, and then plus 8. Make sure you close off that parenthesis. So 22,034.566, or 466. 22,034,466. So x equals 22,034.46. And again, if on our Central Washington exam, if they don't say to give an exact answer or round to 3 digits or whatever, well then either one's fine. I'll take either one. Okay? I feel like if time is an issue, stopping there is a good thing because, I mean, it didn't take a huge amount of time, but getting to this takes a little more time. That's time you could be spending on a different question. Okay? All right. All right, you guys go ahead and try this one. We need to isolate the base first, get it by itself. I'm sorry, not the base. We need to isolate the log function and whatever we're taking the log of. So I got to get everything else to the other side. And then convert to exponential form. Okay, you guys go ahead and try it. All right, so I got to get this part by itself first, which means I have to get rid of the 17. So I'm going to subtract 17 from both sides. If I move it over here and subtract, I just get 3. So I still have 2 log base 3 of x minus 2. Okay, remember that subscript is written a little bit lower. Everything else is written at the same level. Okay, it's just the base for that log function that's written down lower. All right, now I want to get rid of 2. So I'm going to move it over and divide. So I now have log base 3 of x minus 2 equals 3/2, which is 1.5. Okay. Now I know sometimes people look at this and they go, okay, now I'm going to add 2 to the other side. Well, when you do that, you're plucking that negative 2 right out of this function. You know, we can't do that. We're supposed to take the log base 3 of this thing right here. The only way I can pull this stuff apart is to convert it to exponential form. Okay? I can't just pluck something out from inside these parentheses because I'm supposed to do the log of that. Okay? All right, so now I'm going to say 3 raised to this power equals x minus 2. So 3 raised to the 1.5 equals x minus 2. And to get x by itself, I just have to move that 2 over and add it. So I get 3 raised to the 1.5 plus 2 equals x. There's my exact answer. If I want a decimal answer, then I'm going to go 3 raised to the 1.5 equals, and then plus 2. 7.196. Okay? If Central Washington says, give me an exact answer, well then I'm just stopping right there. All right, so I want to take a look at another type of problem, and just kind of reminding you guys of our one-to-one property. Remember, this could go on your note card, right? If log base b of, I'll just go n, equals log base b of m, n has to equal m. So the idea is, if I can just get one log function on each side of the equal sign, well then I could just set these two things equal to each other, right? This has to be equal to this. It says right here they're equal. We got log on both sides, we got the same base. Now if these bases are different, if this is log base 4 and this is log base 10, this doesn't work, right? The bases have to be the same. If everything's the same here, the only way they're equal is if those are the same. So we would set those equal to each other and solve. Okay, let's do one of those problems. All right, so that doesn't quite look like what I just wrote down, does it? I had a log on one side and a log on the other side. So I guess the question is, if it doesn't look the way that I want it to look, could I make it look that way? Could I condense this down into just one logarithmic expression? And sure I can. I chose those words very carefully, right? Because that's what we said when we looked at the properties of logs. We expanded them and we also condensed them. So I would look at this and say, okay, well I'm adding logs. I got to keep on saying this. Logs are exponents. I got to keep on saying that in my head. I'm adding these exponents, and you add exponents when you're multiplying. So I'm going to write this as log of x times x plus 2 right? We add exponents when we're multiplying, and that's equal to log of x plus 6. And so now I have one log on each side. They're both base 10. And that means that this has to be equal to this. Those two things have to be equal. So I'll go ahead and just distribute here and get x squared plus 2x. And then over here I've got x plus 6. And so now I just have to solve that equation. Okay, it's a little more involved. I've got an exponent, which usually means we got to think factoring. And if I can't factor, I've got to use the quadratic formula, right? So let's get everything on one side. We'll set it equal to 0. So I've got x squared. If I bring this x over and subtract it, I get plus x. Bring the 6 over, it becomes negative. You have to do this. It has to be set equal to 0. I still don't think some people have gotten that. And I'm not sure how, because I've said it a lot of times, right? It's got to be set equal to 0. And then once I have this quadratic equal to 0, well then my next step is, can I factor this? Well, let's see. This is x times x. This is either 6 times 1 or 2 times 3. And I want to choose two numbers I would multiply to get this and subtract to get 1. Sounds like 2 and 3, right? If I want to get a positive 1, then what I want is a positive 3 minus 2. And let's just check it. X squared, negative 2x plus 3x, that's a positive x. And 3 times negative 2, that's a negative 6. So that right there says x equals negative 3 and positive 2. All right, the moment I wrote this down, I mean the second I wrote that negative sign, I went, wait. I got to remember, you cannot take the log of a negative number. I got to make sure that doesn't happen, okay? So I need to go back to the original problem. And yeah, if I plug in a negative 3 right here, I'm doing log of a negative 3. Error message on the calculator. Okay, we can't do that. So I need to throw out that answer. And I better check 2 also. Okay, if I plug a 2 in, I got log of 2, that's good. Log of 4, this will be log of 8. And if you really want to know if those two things are equal, you can grab your calculator and go log of 2 plus log of 4. Hit enter. Okay, there's what I get. And over here, do log of 8. So log 8, same answer. Yeah, they're equal to each other. Now someone else might have said, well, Judson, we have that property there, so if you put a 2 there and there, you're going to get 2 times 4. That's 8. That equals 2 plus 6, that's 8. So yeah, it works. I'd say, yeah, it does. That's a good way to check it. Okay. I always like to go back to the original equation, because what if I made a mistake just getting to here? We didn't, but what if I did? Okay. All right, so my final answer here is x equals 2. All right, let's try one more. All right, you guys go ahead and try this one. Kind of the same as the last one, but kind of different. All right, so to use the one-to-one property, I've got to get to the point where I've got one natural log on one side and one on the other. So I have to condense these, okay? And this time we're subtracting with exponents. That happens with division. So I would say a natural log of x plus 1 over x minus 2 is equal to a natural log of x. And now these two things have to be equal to each other, right? I got the same function on both sides. They're both natural logs. They're equal to each other. The only way that happens is if these two things are equal. So I'm going to say that x plus 1 over x minus 2 is equal to x. And then to get rid of the fraction, I'm going to take this to the other side and multiply. We're dividing by x minus 2, so when I move it over here, I have to do the opposite. So this becomes x plus 1 equals x times x minus 2. And now we're starting to look like the last problem, right? X plus 1 equals x squared minus 2x. Since my x squared is over here, I'm going to move all this stuff to the right side. You always want your x squared term to be positive. I think most of us know that, but if you didn't, if I move this stuff over here and I have a negative x squared, that just made factoring harder, right? We're not trying to make things harder, we're trying to make them easier. So I'm going to move everything over to this side. So this will be 0. I've got x squared. If I move this x over and subtract it, I've got negative 3x. And if I move this 1 over and subtract it, it becomes a negative 1. And I don't think this factors, right? So I want to go to the quadratic equation. Okay, remember, and again, this could go on your note card. Quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what I want to do in this problem is I want to say x equals opposite of b plus or minus the square root of b squared. Negative 3 times a negative 3 is a positive 9. Minus 4 times ac. A times c would be a negative 1. All over 2a. Okay. Now, be careful here. I feel like we make it this far and then we start making silly mistakes. Like we go 9 minus 4 is 5. 5 times negative 1 is negative. Well, you can't take the square root of a negative number. Got to remember the order of operations, right? You've got to do the multiplication first. So a negative 4 times a negative 1 is a positive 4. 9 plus 4, that's 13. So I've got 3 plus or minus the square root of 13 over 2. And that doesn't simplify. That's as far as we can go right there. Okay. The only question I have is if I do 3 minus the square root of 13, do I get a negative number? I better check that. Grab my calculator and I go 3 minus the square root, where is it, of 13. Let me just hit enter. We'll get this answer first. And then divided by 2. Yeah, that's a negative number. And if I put a negative number back into the original problem, I've got the natural log of a negative number. Can't do that. So I need to throw out the negative piece. All right, I'm pretty sure if I do 3 plus the square root of 13 and divide that by 2, I'm going to get a positive number. So let me put that in there. We're going to throw out the negative sign, and our answer is going to be x equals 3 plus square root of 13 over 2. Now, you know, if you had time on a test and you wanted to check this, you take your calculator and go, let's see, 3 plus the square root of 13. All right, there it is, divided by 2. There it is, 3.303. 3.303. Use that number to check and see if it works. Okay, you can even do this with your calculator. Use the store button and go store x. So I just stored that value. And now to check this, I'm going to go back up here and I'm going to do natural log of x plus 1. So natural log x plus 1 minus natural log of x minus 2. And then we hit enter. Okay, 1.1947. Now I just want to see if this side equals the same thing. Remember, I stored our answer, I stored it in x, so if I just go natural log of x, it should figure it out. This calculator knows what x is, because we told it, we stored it, right? Look at that, exactly the same, digit for digit, all the way across. So that right there tells me, yeah, I did everything right. All right, that is what we have for today. So we're solving logarithmic functions. Some of them we're going to have to use the one-to-one property, but if we don't have logs on both sides, we're going to convert it to exponential form and then solve that way. All right, let me get you guys a homework assignment. All right, so this is the last piece for week 16. Thursday if you're in third period, Friday if you're fourth or sixth. We got page 254. We're doing 77 to 97 odd. All right, so about 10 or 11 problems in there. It's not a huge assignment. Okay. All right, you guys, that's it. You guys have a good weekend. Take care. Stay safe. See you on, Monday's a day off. Yeah. I'll see you Tuesday. All right? All right, bye.